do unit 1A, which is basically like effects of random molecules motion of gas velocity, which means the molecules of the gas are in constant, which means like the molecules move random motion frequency collided with each other. So, like if we spray like a perfume, like pretend like that's a perfume, and like if we spray it, like basically all the molecules will like, and it'll spread all over. If I spray it right now, it will spread everywhere. Okay, Unit 1B is the combined gas law. The combined gas law is used when pressure, volume, and temperature change. So, and I would like to do an equation. Okay, my equation is the constant volume, the initial pressure of a substance is 0.63 atmospheres, and the initial temperature is 283 Kelvin. Calculate the pressure of substance at 295 Kelvin. So basically, the pressure for P is going to be, my equation is going to be P1 is equal to P2 divided by T1, T2. So for P1 is 0.63 atmospheres, and T1 is 283 Kelvin, and we're trying to find pressure, other pressure, and the 295 Kelvin is T2. So um, so this right here would be 0.63 divided by 283. Sorry for my sloppy hand. And we're trying to find the other pressure and 295. Okay, and then we will cross multiply it. And then we get the answer. And next, I was talking about standard pressure. Basically, standard pressure corresponds to 273 Kelvin. So in one atmosphere. And standard pressure is often used for measuring gas density and volume. And next, next unit for my unit, it'll be temperature scale. And now we'll answer this question right here. And the question is, what is absolute zero, and why is it called absolute? Why is it called absolute? It is zero on the Kelvin scale. Is equivalent to negative 273, which is the reason why it's called absolute is the coldest temperature possible. And for my last unit, which is the idea gas law, and I will solve a problem for that, and my equation for that is Pifler. So it's like P, Z, N, R, T. And my equation is as Tyler is inflating a balloon. She can generate 1.5 atm of pressure at 300 Kelvin. If she inflates the balloon to 3 liters, how many moles of gas are there? So so one atmosphere is P, and 300 Kelvin is the temperature, and the 3 liters is N, and then we're trying to find the mole. So that would be N. And we don't always have to use R. And so 1.5 equals 3. Oh, oh, I'm sorry. This is. I go back to my other slide, Issa,
Why so?
for this one.
Meters. Okay, well, Kelvin. What's Kelvin?
Kelvin
Is it going to be, so you put pressure, you put N, so all you're left with is V, volume or temperature? Which one's volume and which one's temperature?
this would be temperature.
Yeah, it is. Here's the Kelvin. And then volume would be which one?
This one.
Correct.
And then this is the unit. Thank you. So it'd be 1.5. Oh, 3 is equal to. Oh, we're trying to find N, the moles, and the temperature is 300. And all you do is divide this one because it has a variable. Divide these to 300 to both sides, and then you get the answer.
Alright, cool. Okay, so, in your own words, Aysha, can you tell me what is temperature?
Temperature is basically like
So like, okay, no, don't sit. Look at me. Okay, so in terms of the molecules, if we said that a gas is heating up, what is happening to the molecules?
the molecules will be slowing down.
They're slowing down.
Yeah.
So if it's cooling down, the molecules are moving faster.
No.
So tell me then. So when a gas heats up, what's happening to the molecules?
They're like,
Or when a gas is cooling down. So for cooling down a gas, what's happening to those molecules? How are they moving?
moving
Faster or slower?
slower.
Slower, right? And if they're heating up, they're moving.
Faster.
Okay. So you mentioned that absolute zero would be the coldest temperature possible. And remember, as we cool down, they start slowing down. So can you explain to me why would it be that if we cooled the gas all the way down to absolute zero, why is that the coldest temperature? What's happening at absolute zero? Why is it called zero? How are the molecules moving at zero? Or are they moving at zero? They're not, right? Okay. Can you go over standard STP one more time? Can you go back to that slide? So the one dot C. Can you go over that one more time for me?
Standard pressure is it corresponds to 273 Kelvin and one atmosphere. So basically, like standard pressure is often used for measuring density and volume.
Okay. So at standard temperature and pressure, there's a special conversion factor we can use. We can always say that 1 mole of gas equals a certain amount of liters. Can you tell me how many liters that is, by any chance? Remember? 1 mole equals how many liters? No. Okay. Okay. Alright, cool. Okay, awesome. Thank you, Aysha. Next is Sebastian. Yes? Good? Yeah? Awesome. Okay. Here we go.
If I have a 30, 60, 90 triangle and on the side one of them is square root of 3, can I do that one? Like, let's just say for practice, is the triangle right? Like one of the sides or one of the legs is square root 3.
Yes, the one that has
Okay.
Alright, so Kayla, you're gonna observe Sebastian.
Sebastian, is this your final? You guess why I'm asking if that's your final?
Because I wrote it. Oh no, not my name on it.
Yes, you forgot to write your name. I was wondering where yours was. There we go. Sorry?
What the heck was this? Sorry. Was I that loud?
Yes.
Yeah.
That's embarrassing. Huh?
I thought it's because my earphones are in, so
15.
everything I say is a lot louder than when I
You're still
think I
talking.
hear it. Okay, I'll stop.
God.
You can get notes on the slide.
Huh?
You can have side notes.
Yeah, it's pretty cool. Alright, so you're gonna start with
I'm starting
math?
Yes.
Of course. Scott, would anyone start with chemistry?
Well, no, because I was waiting for my test and I haven't gotten it yet, so I was just.
Okay, don't worry about it.
Should I
Alright, that's